Which is bigger, sodium or chlorine? And why does atomic size change across the periodic table? To answer this, we need to understand atomic radius, which is used to compare the relative size of atoms. But an atom has no fixed outer boundary. Its electron cloud gradually becomes less dense as we move away from the nucleus. So, atomic radionucleus to the outer region of the electron cloud. Because we cannot directly see this boundary, atomic radius is usually determined from distances between the nuclei of bonded or nuclei of two identical bonded atoms. For example, in Cl2, half of the Cl radius of chlorine. For metals, we can use metallic radius, based on the distance between neighboring metal atoms in a metallic crystal. For non-bonded neighboring atoms, we use the van der Waals radius, which is generally larger than the covalent radius. Now comes the important part. How does atomic radius change in the periodic table? From left to right across a period, atomic radius generally decreases. As we move across, the number of protons increases, so the positive charges. At the same time, electrons are being added mainly to the same principal shell. Since the new electrons enter the same shell, the increase in shielding is relatively small compared with so effective nuclear charge increases, pulling the electron cloud closer to the nucleus. That's why atomic radius generally decreases from left to right across a period. Now move down a group. Atomic radius generally increases. Every step downward adds a new principal electron shell, placing the valence electrons farther from the nucleus. More inner shells also mean greater shielding, which reduces the effective attraction on the outer electrons, so the electrode becomes larger, and atomic radius increases down the group. Therefore, atomic radius generally increases downwards and towards the left of the periodic table. But atomic size changes dramatically when atoms form ions.